It is top of the hour. Good evening, everyone. I welcome you to our webinar today. I am Yashima Jain and I'll be moderating today's session. All right. So in today's webinar, the speaker will demonstrate the features of DesignBuilder that can be used for effective net zero building design. Through the software interface, the speaker will discuss the application of various energy conservation measures and understanding the results to make effective design solutions. I would like to acknowledge the support of Department of Science and Technology and the Ministry of New and Renewable Energy. I would also like to acknowledge the support of our sponsors and affiliates for Solar Decathlon India. Now, before we begin the webinar today, I would talk very briefly about the Energy Performance Index targets with all of you. EPI targets, just to give a brief introduction, the information in the following slides is intended as EPI, which is the Energy Performance Index, and it is for each climate zone for super efficient buildings, for example, ECBC super levels that have the potential to achieve net zero energy performance. The data represents the technical potential of cost-effective approaches available in the market. And these targets are based on simulation studies and are to be treated as benchmarks for guidance. And kindly note that performance for your building design may vary based on your exact project location, your design, and the use of your building. Now, to give an example, when we look at hot and dry climate, I'll briefly explain what the graph here indicates. So we have four building typologies for Solar Decathlon India, which is office, residential, educational, and community resilience shelter. So the graph here depicts end uses along with the EPI numbers for all these four buildings for hot and dry climate. Now, when it comes to end uses, you can see fans, pumps, cooling, heating, lighting, and equipment. And the overall EPI number is given in red at top for each building typology. Similarly, we have results for warm and humid climate, then cold climate zone. Next is composite climate, and the last is temperate climate zone. Now, these results will be shared with your faculty lead and your team lead, and you can reach out to them if you want this information. And lastly, we would like to acknowledge the support of Environmental Design Solutions and the National Renewable Energy Laboratory, also known as NREL, for providing data and guidance. And also kindly note that the EPI targets of the office buildings and educational buildings are based on the data provided by EDS, whereas EPI targets for community resilience shelter is based on combination of office and educational buildings. Also, the EPI target for multifamily residential units are based on energy simulations done by the National Renewable Energy Laboratory.
Yashima, I want to add something here. So
sure.
It's sort of like, say I were one of the energy simulation people on one of the teams, then I know that my climate is going to be, say, warm and humid, because let's say I have a building in Mumbai. So I would go to the climate zone for warm and humid in these set of slides. And then I would say, okay, I am, my project is an office building. So I look at the office section and I say, okay, it's an 8-hour office building. So then I'll say, okay, so it's expected that in the warm and humid climate, which actually ranges all across India, you can see there, it's the entire coastline, not necessarily just Mumbai, but 71 seems to be the target for that entire climate zone. So obviously, based on the fact that, the actually building may be in Calcutta, it may be in Chennai, it may be in Mumbai or somewhere else, those results may vary a bit. Also, if I am designing my building differently, I'm not going to end up at 71. But what 71 tells me is that it's not going to be 183. It's not going to be 37. So I get some idea of where my results ought to lie. And that's the reason that we are providing these graphs to you. These are simulations that are done by experts who have looked at technologies of trying to make buildings efficient. So, so while these are template designs and sort of technical potential type of approaches, it does give you some idea of how these numbers can be used, and treat them as a guidance, not as the absolute truth of what the EPI numbers ought to be. That's it. Thanks, Yashina.
Thanks, Prasad. So we'll move ahead. So today we have with us Arjun Desai, who is a civil engineer with added skills in energy efficiency in buildings. He has expertise in dynamic thermal simulations, thermal comfort, low energy cooling systems, and data analytics. He works at the Center for Advanced Research in Building Science and Energy, also known as CARBS, at CEPT University. Currently, he is also pursuing his second post-graduation degree in artificial intelligence. He was the team lead of the energy analysis for the first team from CEPT University to take part in the US Solar Decathlon competition. Welcome, Arjun. Now, as always, to all our participants, please feel free to send in your questions at any time during the webinar, and we will take as many questions towards the end of the webinar. And with that, it's over to you, Arjun.
Yeah, hi Ashima, thank you, and hello, welcome everyone. Today I will be talking about how you can use DesignBuilder to create your geometry and do your energy simulations. So I will walk you through a few of the very basic things in DesignBuilder. So I'll just share my screen. Just a second. Yeah. So
yeah, your screen is visible now.
Visible? Yeah. So the agenda for today will be I'll be talking about creating templates, various kind of templates in DesignBuilder. Basically, there are 4 main types of template, which is activity template, construction template, opening template, and lighting template. I'll be also talking about how to size your cooling equipment, be it your HVAC, I mean your split system or chiller based system. So how to right size the system, how to operate in a natural ventilation mode, and understanding the results. So whatever the results that you are getting from DesignBuilder, how to interpret those results and how to convert your EPI numbers into relevant INR and other post-processing methods of the results that you are getting from DesignBuilder. Next. So this is the model that I'm going to show you. This was the model that we submitted during our Race to Zero, or previously known as Race to Zero and currently known as Solar Decathlon US. So I'll be showing you this model today. And this is what it looks like in DesignBuilder. It is very different from your architectural rendering. So if you see this pane here in the left side, this pane shows the hierarchy of the building. So on top it is a building, then you have your Hvac system, that is block 1, block 2, and inside each block you have your each zones. So block here I have defined as one floor as one block. If you go to a block level and if you see this, I'll show you from top view. Here you can see different view. So if you go to plan view, this is how it shows. This shows, the circle shows the north, So this is how we created the zones for our model. This is the kitchen, bedroom, this is toilet, these two are shafts. This is the central portion is the staircase, the living room, guest bedroom, and it's what toilet. So if you go to block 2, there are similar spaces here in block 2 as well. So I'm assuming that right now you know how to rename all these blocks and zones in DesignBuilder. So right now, let's move on to our first thing, which are the templates. So let's go to the activity tab. In the activity tab, as you can see, there are the main template here is generic office area. Inside each template, you can define all these values that you are seeing here. I'll walk you through all of them one by one. So the floor area and volume of the building or the space is automatically calculated based on the geometry that you don't need to enter here. There is this occupancy. So occupancy is defined here as density that is people per square meter, and you can also define schedules for occupancy. I'll walk you through schedules also. Okay, yeah. Thereafter, there is metabolic rate of people. There is clothing level of people. Basically, these clothing level will be applied to the occupants, and it will be used as per your occupancy schedule. There you can also define holidays. If you have, like, if there's an office building, then you can define your holidays. You can define specific days where there will be holidays. You can define your domestic hot water consumption rate, and then in the environmental control here, you have to set your set points for heating and cooling. So there are two things that you see here. One is heating and heating setback. So set point and setback both have different meanings. Set point is the one that you usually keep on your air conditioning. So suppose in your home you want to keep the AC at 24, the 24 becomes your set point. And setback is something that you want to operate your building when your building is not occupied. So let's say that no one is in your home and still you want to keep your home cool. Let's say, but not at 24 degrees. Instead of 24, you can maintain it at 30 degrees. So this becomes your setback. So whenever the building is unoccupied, this setback temperature comes in. The comfort set point is basically if you are aware about the thermal comfort models, different thermal comfort models or predicted mean votes and all, you can keep PMV as a set point. So I mean your air conditioning set point won't work at that time. It the set point that will come in is the PMV set point. So on a thermal scale of -3 to +3, let's say your thermal set point is -0.5. So it will automatically, the software will automatically calculate the indoor air temperature. And whenever the temperature lies within the range of -0.5 to +0.5 or -0.5 to 0, your air conditioning system will not work. And as soon as your comfort temperature goes outside of -0.5, it starts working. So this is how the PMV comfort for heating and cooling works. Again, humidity control. If you have a humidistat at your home or in your air conditioning system, or if your system, then you can use this humidistat. So basically what it does is it can maintain a specific humidity, just like set point. That's it. Ventilation set point temperature. So if you are using natural ventilation, so what is the set point that you want to keep? So if 24, by here 24 means that whenever your outdoor air temperature goes below 24 degree, you can start using your natural ventilation. Or whenever your indoor temperature exceeds 24 degrees Celsius, you can start using natural ventilation. But at the same time, it should also be like that your outdoor temperatures are within the comfort range or are below 24. Otherwise, your natural ventilation won't work. In the minimum fresh air here, it is the basically ventilation rates that you set. So as per the ASHRAE, you need to set as per ASHRAE or ISHRAE. There are standards available where you can see what is the minimum fresh air that a human requires. So right now it's 10 liters per second per person. So if there are like 50%, so you just multiply 10 liters per second into 50. So that becomes your ventilation rate. Yeah. And for lighting, right now I'll talk lighting. Here is the target illuminance level. You can keep it at 300, 400, whatever your standard specifies by the activity what you are doing in the space. So generally for reading and writing purpose, we have a 300 lux standard. You can keep more or less depending upon your usage also. Another is computers and equipment. So if you have any computers here, you can just mention your computer, number of computers, the power density, and the schedule whenever the computers will run. Radiant fraction, right now you need to look at different standards of what the radiant fraction of computers will be. You can also ask manufacturers if they give the radiant fraction, which I don't hope that they will give. Then there is office equipment similar to computers. You just need to give the equipment power density of the space, and you give the schedule of your equipments and radiant fraction. Others will be any miscellaneous, like other than office equipment and computers. If you have any miscellaneous equipment in your home, you can just enter those. And then there will be catering. So in the catering, there will be, let's say, cooking, and in the kitchen, basically it will come, the catering part will come in kitchen. Or if you are in a hotel kind of building, then the catering loads will come, otherwise it won't come. And lastly, there are process loads. Process loads mainly come in an office building kind of scenario and not in a residential building, where let's say if there is a laboratory, then the process load comes like the laboratory equipment that are specifically used in that laboratory, that becomes that the process loads. So all those loads you have to mention in the activity tab. Now you can make different templates for all of them. Let's go through one template. So let's go to the overall template, wherein you have to define all these inputs. So I click on the plus icon here to create a new template. Sorry about that. Yeah. So if you see here it will be just the name of the template. Let's say here so I'm just naming this as Solar Decathlon India test. The category I can choose whether it's an office building template or a residential building template, or there are many different type of buildings here. You can keep any of them. Right now, let me keep to a residential space. Yeah, and if there are holidays, then just check, and then you have to define your holidays later on. Yeah. So all gains right now, because I have it in, there are, before this section, I also need to show you one more section. The power density here that you see is basically the power density of all the equipment combined. So let's say you have 15 equipment in your house overall. So you just calculate the rated power of all that equipment, and then divide it by the total area of your building or your space, and then you give here the power density of that. So that becomes your power density, and you input here the occupancy here. So as showed, it's office workers, or you can see if it's residential, what are the kind of occupants that are going to occupy the space. So there are like married couple, employed, or codependent, or whatever. And if it's office, then it's office workers. So let's keep this. Density, you can mention people. I mean, if there are just two people in the house, and you know, a house is 180 meters square, so we can have 9, let's say, whatever. I mean, I'm not calculating right now. You can say 0.005 people per meter square, whatever. You need to calculate this and enter there. Number of people you need to enter here. Let's say here we have just 2 people. So enter here. Latent fraction from people. Again, there are different standards that suggest what is the latent fraction emitted. I'm not going into very deep of all these concepts right now. But you can look up into ASHRAE or ISHRAE standards where they provide what is the latent fraction. Metabolic rate, what are the occupant doing for most of the time. So let's say if they're sleeping, or they are walking, bedroom dwelling, or reclining, or whatever it is, standing relaxed. So this kind of activity level, this activity basically defines what will be the metabolic rate of the people occupants. And then there will be this workday profile. So if you say the work will be 8 to 18, 18 means 6 o'clock. So let's say from morning 8 o'clock to 6 o'clock, and a 5 days work week. This becomes a typical office scenario. But if we have a residential scenario kind, then we can just probably shift here. Yeah, like this. And let's say 8 to 18 people are not going to be home. And this is the 18 to 8, they will be at home, right? So, and in the schedule here, you can define your schedules. So there are multiple ways in which you can define the schedule. I'll just replicate this one and edit this. Where did it go? Oh, yeah. Yeah, this is the edit symbol. So if you see here, sorry, yeah. So the way this schedule is defined is 7/12 schedule. What happens here is on the columns, it says Monday, Tuesday, Wednesday, and till Sunday, and the rows are months. So for in January, every Monday will have this schedule, every Tuesday will have this schedule, Wednesday this schedule. So you can define day-wise schedule for the days. You can edit individual. Just a second. Let me just hide this. Yeah. You can edit individual schedule also from 8 to 18 if you want to do 8:30 to 16. So you can just say that all week in January, all Mondays are going to be this. Otherwise, the schedules will remain this. Other 8 to 18, right? So you can do that kind of thing also. Or if you want to change every schedule, you can do that also. So if you want to edit this schedule, what you can do is go here. And let's say I already have this my schedule created, bedroom schedule, and I'll click on edit. So what you can do is just select here and just drag up or low. I mean, then you can select that, okay, at this time there will be a 50% occupancy in my bedroom, which will be between 6 to 7 hours. If you want like between 7 to 8, there will be also 50% occupancy because there are only 2 people. If there are more than that, you need to calculate a ratio as well. So like that, you have to calculate the ratio of occupants that are going to be there in the space, and then you need to input here. So you just simply drag from bottom and like this to input the values. Yeah. So if you want to apply this schedule to all the days, so you simply select like this. Just click on the name of the day and it will select the entire column, and then just double click on whatever schedule you want to give. It will get applied to all those things. Okay, similarly, if you want to do for month, you can do similarly like this. Yeah. So this is how you edit schedules in Design Builder. Now this is a 7x12 schedule. There is a day schedule and a compact schedule. In compact schedule, you need to write a script here, which I think it will be very difficult for you to understand if I start writing scripts here. And there is a day schedule, which is also very similar to script. Here also you need to write scripts. But the 7x12 schedule is very easier, and also it gives more flexibility in terms of inputting the values and uh, implementing the schedules for each particular days and all. Yeah. So this is my schedule, and I will keep it at, let's say, RTZ1. Let's say this, and I click on OK. So now this becomes my RTZ1 schedule. Occupancy. This is my occupancy schedule, and I'm applying this occupancy schedule here. Let's go to other gains. So now there are computer, office, miscellaneous, and all those gains that I mentioned earlier. You need to enter here the power density of computer. Let's say your power density right now is 10 watts per meter square. So you need to calculate that if you have computers in your space, what will be the rated power of that computer. You need to divide that rated power by the area of that space. That becomes your power density, and then enter here. And also, if you want to enter the absolute power, let's say if we have 90 watts PC or laptop, 90 watts laptop, we can directly enter 90 here. And then radial fraction, it is a default value right now at 0.2, but you can see the different standards that they have already published the radian fraction of different kind of systems. So you can use that. Again, the workday profile, as I showed you in the occupancy gain, it's similar to that. I am right now creating this 8 to 18 workday profile. Yeah. And then similarly here you can just give whatever the schedule you have for computers, you can enter here. The same goes for office equipment. You can define all your power densities and absolute power, your day profile, your schedules, just like what we did in occupancy schedule. Enter here, everything goes same. DHW, if you require domestic hot water, again, you specify what is the consumption rate of your domestic hot water liter in terms of liters per meter square per day. So just check the units before you enter any number. So it's not liters per day, it will be liters per meter square per day. And then the schedule of what will or when will your domestic hot water be used, the schedule for that. This is the environment control tab where you will input the set points. So let's say for my case, Ahmedabad, I don't need a heating set point. I only need is a cooling set point. So I will leave the heating set point as it is. Or if you don't want to heat, you can just say heating set point to 0. So it will not heat anything, and cooling set back to 0, right? So the heaters won't operate at all. until and unless your temperature goes to minus. If your temperature goes below 0, then your heaters may turn on and keep the temperature to 0, otherwise they won't operate. And then then the schedule doesn't matter. The cooling set point, yes, the cooling set point, let's say I want to keep at 24 or 26, maybe whatever, it's fine. And the setback should be always higher than your set point. You cannot keep your setback at 10 and set point at 26, it will throw an error.
Just one thing, Arjun. So in the interest of time, I think we can, we'll want to focus more on cooling size, and we
Sure.
talking about results. So
Sure.
yeah.
No worries.
And also running the ECMs, right?
Yes.
Yeah.
Yeah.
Okay.
Yeah.
So once you enter this, then again the schedules are the same, and as I said, ventilation rates will be as per the standards. So this becomes your activity template. I'll just click OK, and your activity template will get saved. I don't know where it got saved. Might be in the residential area somewhere. Yeah, this one. And then when you apply the template over here, all your values here will automatically get changed. So you don't need to enter any values over here. Once you define a template, an activity template, your every values will be automatically entered, and it will be taken from the template itself. Now I'll go to construction template. Same as the activity template. There is one template over here which defines all these values. So in the construction, you have external walls, below grade walls. So I'm not going to explain all these terminologies right now. You can look it up here in the help section of DesignBuilder. All of these are pretty well given. I'll just show you how to create templates in here. So these are the templates that we already made during our Solar Decathlon or Race to Zero. So here, as said already, name. In the walls, you need to select how you construct your walls. How many walls do you want to have? So let's say for the external walls, you have this, and I want to, suppose if I want to construct a new wall or I want to edit a wall, this is how it looks. So you enter the name of the wall, how many layers, I mean, what method of definition, what definition you want for the wall. Right now it's layer by layer. So you can also set a direct U value from here, or you can have a layer by layer definition also. So right now we have layer definition. We have three layers of walls, the outermost layer, the inner layer, and the innermost layer. So this becomes the middle layer. So the outermost layer consists of plaster and the thickness. So you select from a range of material that is already given in the DesignBuilder database, or if you want to create a new material altogether, then you need to have the properties of the material, and then you can add basically new material as well. But for the purpose of SDI, I think the materials that are already available in the database will work. But if you have all these properties with you for the material, then you can construct your own material, and then you can use it. Right. So the name of the material, the thickness, again in the second layer, the name of the material and its thickness. Mind me that the thickness of the material is in meters. So just keep in mind. Then again, material and thickness. So once you enter all this, you can see the image of whatever you have constructed or what your wall construction assembly. And in the calculated, you can see the U value of your wall or your construction assembly. So this is 1.8. So depending on your construction assembly, the U value may vary. If you are using insulation, your U value may even go down. So this is how you define each of the walls. And even in the roofs and slabs, you have to construct this, all the roofs and slab in the similar manner. Just you need to be very clear about your construction assembly or what you are going to construct. If you are clear about that, then you can make these templates on your own very easily. And it's very similar to what I showed for walls. If you see, yeah. So it's same as the wall. You have to just define your layers and your construction assembly gets constructed, and then you can see the U value in the calculated here, and then yeah, yeah. So this is how you set a template for your construction. You can also add thermal mass over here. So in the thermal mass, you can have like if you have a brick wall, and this thermal mass is your internal walls. So if you have a concrete wall, you can add a thermal mass of concrete. If you have a brick wall, you can have thermal mass of bricks. So just select the materials that you want. I mean, that is there for your in partitions. So let's say 105 mm brick, plaster both sides. So this becomes my internal thermal mass, right? And then save, and then whenever you apply it, template over here, all those things get accounted here. It will be reflected in all these uh, tabs. Yeah, and then there is this model infiltration. So infiltration is basically the amount of air that gets leaked inside the building through the cracks. You can set that also. Next, we go to openings tab. Uh, in the openings tab, we define the type of glazing, the layout, and in the dimensions, you can enter the window to wall area ratio, window height, spacing between two windows, the sill height, and the reveal depth. And how you are defining it is also there here. If you are saying preferred height, so it will be uh, the design builder will fix the height at 5. Uh, I mean height at this 1.5 meter, and then it will adjust your width of the windows as per the window to wall area ratio. If you say continuous horizontal, then it will have a continuous horizontal strip. Let's say I'll show you this, and I have a 30% window to wall area ratio. Then you can see a continuous strip kind of wall comes. And if you have a fixed width, there will, I mean, a fixed height, then yeah. So your height will be fixed at 1.5 meter, and then it will calculate the width of the window automatically, and then place the windows as per the window to wall area ratio entered. Yeah. So, and then there are doors. You can do auto generate doors and their operation, or you can manually place the doors. Okay, and I will show you how to define the lighting template. It's very similar to construction template itself. If I edit this template, the name of the template, you select the glazing from here. So there are a lot of glazing already available in the design builder, or you can create your own glazing, but then you need to have values from the manufacturer of whatever glass you are using. So for external glazing, you have to select this. I mean, give the glazing whatever you need. Let's say single clear 6 mm, and the kind of frame that you have. If you have aluminum frame, you can select aluminum from the options or from the available list of options. If you have UPVC, you can have UPVC. And then the percentage glazing area opens. Let's say if your window is opening just 5%, then you have to enter 5. Or if you say your window is fully operable, or you have a casement kind of window, then it comes to like 90% of the glazing area opens. And if you have a sliding window, then your opening area becomes 50%. Like if a 2 sliding windows, then if you have a 3 slider windows, then it becomes 30%, and so on. This becomes, here you can define your internal glazing. So in between the rooms, if you have windows, so that glazing comes here, and the roof glazing comes here. So if you have a solar light kind of scenario, then you have to enter the roof glazing in here. Then you enter the shading. If you have a window shading, what kind of shading? Is there a blind? What kind of blind or micro louvers or whatever, sage glass, electrochromatic, or diffusing shades, drapes. So all kind of shading comes here. You have to select one and control type, if like what is the schedule, if you want to control it by the schedule, or you want to control it by the solar loads or glare or cooling. So different types of control strategies are available for your shading. If you have a local shading, basically overhang or so, you can have select 1.5, 1 meter, 2 meter, whatever the overhangs. If you want, you can construct your own overhangs with you know 1 meter, 2 meter, or 0.3 meter, 0.8 meter, whatever your custom shadings you can create over here. Similarly, for louvers and side fins, you can use louvers and side fins also. You can construct your side fins and louvers by all this, inputting all these values. Yeah. So this is how you define your glazing template or your opening template. And you, once you apply the template over here, all of these values will be used as per the template. Right. The last one I'm going to show is your lighting template. So whatever kind of light you are using, with this LED or CFL, you can enter those templates over here. All these values, basically in the template, you have to enter all these values. If you see, it's just you keep this. Output is power density and absolute power, and what is the kind of fixture that you are using. So luminaire type, you can see what are the kind of luminaire types in the example over here, and just what will be the visible and radiant fraction. It will be used to calculate the heat loads inside the building. And then you apply the template over here. Lighting controls, if you have lighting controls in the building, then you can use this lighting control. Otherwise, just keep it as it is. Yeah, so these becomes the templates. I'm not going to talk about HVAC systems in this webinar, because we will be already having one webinar in the future dedicated to HVAC systems. So once all these inputs are defined, you can just run a simulation and check what's the energy consumption. Right now, I'm not going to simulate because it will take time, and I will be just showing you that how the simulation tab looks. So when you go to simulation tab, you just need to update the data. Yeah. And it will ask you about at what interval you want to run the simulation, whether you want to do an hourly simulation, a daily simulation, or a monthly simulation, or run period. And if you want to run for multiple years, and also select the run for multiple years, it will run for 5 straight years. And you can also define, if you want an annual simulation, you can just click annual, or if you want summer design week, summer typical week, you can select just all these are preset, and this will take from the weather file. The summer design week will be taken from the weather file. Or if you want to custom run for few days, you can just input the date and month, and it will run for those period only. The options, we are not going to talk about options here right now. These are much detailed things. So for right now, you can just use this and simulate. Right. So the next thing was the cooling design tab. So once you have defined your HVAC system, which you will learn in the next webinar, how to define an HVAC system, you can go to this cooling design tab. In the cooling design tab, it will run the simulation for one particular design day. So you can select that. Okay, 15th of July is my summer design day. If you want to include heat recovery or not, let's write exclude heat recovery. So for this period, it will calculate sensible plus latent, and we said okay. It will simulate for one day, and it will give you the cooling design or your cooling load for that particular day. So based on that cooling load, you can size your HVAC systems right. Okay. Advanced. Wait. It comes under this. Check for non-convex zones. Okay. I'm canceling. So this error comes when you have zones that are not connected, or basically if you have partitions that is not standard partition or virtual partition in your model, this kind of error comes. Right now I do have a virtual partition in my system, in my model, and hence I'm getting this error. So Energy Plus won't allow me to simulate this thing. So always have a standard partition. So basically when once you simulate in cooling design, it will show you results. Let me try one more time again, if I can show you. Exclude heat recovery outputs, advanced. Yeah, here it is. Okay. So meanwhile, when these results are loading, okay, it's loaded. Yeah. So this is how you see results in Design Builder, and you can, instead of graph, you can use tables. It will show you in numbers, air temperature and all. So if you see here, sensible cooling, zone sensible cooling, instead of all, let's say internal gains. Right? So these are your gains, sensible gains for all the period. You have to just total them, or you go to summary. In the summary tab, you just see the total over here. So design capacity, you see 43.2 kilowatts of system. which is what you require to cool the building. So this becomes your cooling system size, and this is your total cooling load, 37.41. So this is how you size your system by running a cooling design simulation for one day. Next, I will show you how to use the ECMs, right? So I'm not running all the simulations, but let's say that in the construction, you want an ECM. Let's say that for your one ECM is a wall with a lower U value, right? So if I say I want an AAC block with XPS, so let's say this XPS, I have this wall. So I input this XPS wall in the template. I mean, I have already constructed this template during the place 2.0. I'm just using the template right now, and I again run the simulation, and it will give me some EPI. Okay, so what I'm going to show you is I have already run few simulations over here. So for, let's say, this is a BAU building or a business as usual building, the baseline model, we can say that, which is having a 230 mm burnt brick walls. For that, the EPI comes around 119. Of the EPI or of the total energy consumed, these 11,000 unit goes into cooling, 4,600 goes into lighting, 4,800 goes into equipment, and rest goes to the fans. So this is how the breakup looks like. If you have other kind of system, you can also have pumps, pump energy also showing in here. Right now, the simulation that I did not include a pump, so I do not have a pump energy here. So if you see different kind of walls here, you can see the reduction in the EPI in this graph shows just by changing the wall, rest all the equipment power density or the lighting power density and rest everything is the same. Just I have just changed my wall U values, and you can see the reduction in EPI. It goes from 119. Then if you have XPS on top of burnt clay brick, it goes to 112. If I'm using just 150 mm AAC block, my EPI comes to 113. If I'm using AAC block 200 mm, it further reduces. If I'm using XPS on top of AAC block, the EPI again goes to 104 from 119. So this much reduction can happen just by changing your value values. Similarly, if you have in terms of window to wall area ratio 30, 10, 20, 40, 50. So 30 is my baseline, 30% window to wall area ratio. This is without shading. So if you have your window to wall area ratio is 30%, 119 is the baseline, and then for 10% it goes to 107, for 20% is 113, and so on. So if you see here that the lighting equipment energy does not change because it does not depend. I mean, your lighting and equipment does not depend on your windows or your wall construction or shading and anything. It is just what the LPD and EPD that you enter. The only change you will notice is in the cooling and the fans. So these are the energy that is mainly affected by your construction or any of your ECMs. Similarly, if you have shading, your EPI goes further low. Like if you don't have shading, your EPI was 9119. If you have 0.5 mm, I mean 0.5 meter overhang, your EPI drops from 19 to 15, and so on. If you have different kinds of shading, different EPI. Now, I just want to say that these reduction in EPI is specific to this model. This is not a generalized reduction in EPI. So it doesn't mean that in your model also the EPI reduction will be same. Now, if you have lighting, changing lighting, so lighting energy also changes. and your cooling also changes, because lighting do generate some kind of heat while operating. So all of your lights, so if you have 10 watts of light, you are generating 10 watts of heat inside the space along with light. So your cooling load will also change with your LPD and your EPD as well. But EPD is not considered in one of the ECMs, so we will not talk about EPD in ECM. What remains now is exporting the results, and I will also show how to operate your building in natural ventilation. So to operate your building in natural ventilation, you go to the model option over here. And in the natural ventilation and infiltration, you just keep it in calculated and just keep OK. And then go to Hvac tab. Check on the natural ventilation in here. Now, right now, because the Hvac is in detail mode, it will not take. But just keep check on the natural ventilation on. And you can define your schedules and set point temperature as I suggested earlier. And then go to openings tab. And then you will see an operation for Windows over here. Right. So from here, you can define your schedule at what time or at what temperature you want to keep your windows open or closed. So this is how you define your natural ventilation model in DesignBuilder. Now I will just export the result that we got over here. Okay. Something is changed. Yeah. So let's say you have all these results. You just click on export dialog. You say text or data. Okay, and then just file, or let's say clipboard. Okay, and then you export all data. You want it in a tabular format, and subset points and point subset will keep point subset. So points will basically be the columns, or your air temperature, radiant temperature, and all will become in the columns, and your data will come as rows. If you keep the other way around, it will be inverse. So I will just export. So right now everything is copied in my clipboard, and I will just paste it over here. So this is the timestamp, and these are all your parameters that get exported from the DesignBuilder. And then you can post process it in whatever ways or you want, whatever graphs you want to plot, or whatever investigation you want to do. You can investigate your results through Excel and graphs. So right now it's just a 1 day, but when you simulate for when you do the simulations for hourly and for annual, then you will get 8760 rows over here for 8760 hours in a year. And then you can investigate at that what's happening in the summer or what's happening in the winter in this particular space, and so on. So you can even go to individual spaces in the bedroom. Let's say if you want to analyze a result in the bedroom. So you right now whatever I showed was at a building level. You can go to bedroom. You can just export the dialog to text, and the clipboard, export table, points offset, export, and then go to any Excel file and then just paste it. Now these are the results for your bedroom. So if you see, so overall temperature of the house showed at 27.61, but your bedroom temperature was 25. So what Unbuilder does is, if you go to building level, it will just average out, or it will be a weighted area average of all the spaces, and that will be shown over here. Versus if you go to, if you want to investigate the results in each spaces, you can just go to each individual spaces and then export all these results and check what's happening in each of the space. So this is how you export the results into DesignBuilder, into Excel, and then you investigate and plot the graphs as you want. The last topic that I wanted to talk about was thermal comfort. So if you want, I mean, I will not be going in much detail about the thermal comfort. This is a custom sheet that I made. If you want to calculate, thermal comfort, or the comfortable hours, number of comfortable hours in each space, what you want to do is you need to calculate 30-day running mean of each of your space or of your location. So the 30-day running mean you can calculate by using an hourly outdoor weather file. From the 30-day running mean, using the equations of the Hvac, you can calculate the neutral temperature and the upper band and lower band of whatever acceptability range you want to define. It is 90% and 80% right now. I have calculated for both. If you want your space to be 80% comfortable, then you use 80% band. If you are using 90%, then you can use this band. Once you have this band, I have my indoors temperature. What I did was I took the indoor temperature, this temperature, into the sheet, and then I use that if this temperature, my indoor temperature, is lying within the upper band and lower band, you calculate it as comfortable. If it's not lying within the band, it's not comfortable. And then finally I summed it down here. That becomes these many hours are comfortable for that particular space. Now, so this is how you can see or calculate the number of comfortable hours. And then if you want to plot, you can also just plot that, okay, at what time my temperatures will be within the comfort range and what time it will be outside the comfort range. That's it. You can see like this. Yeah. So that's it. I'm ending my screen share. So if you, let's have the question and answer session now.
Yes, thank you so much, Arjun. We'll jump right into the questions now. We've had a few questions coming in. So the first question is, while simulating cooling day for a single day, the load which comes is the peak hour, is of the peak hour or an average of the whole day?
Yeah, so the load that comes will be peak hour. I can show you, or I showed you. 1 second, I'll share my screen and I can show also. Yeah, so if you can see in the table, or if you can see in the graph, you can see this peak comes somewhere over here and somewhere over here. This is outdoor temperature, and your indoor temperature peaks somewhere here, maybe, right, in the bedroom. If you go to a building level, your peak indoor temperature comes somewhere over here, and then you go to summary. It will show you the peak, and it will also show, I guess, when the peak is occurring. Yeah, the time of maximum cooling. If you see that at this particular time, all these peaks are occurring. So what DesignBuilder is do is, let's say for staircase, my peak cooling comes 3.54. It comes at 4 o'clock in the evening. Versus for my bedroom, it comes at midnight. I mean 9:30 in the night. Okay, so it will take this peak load and it will just sum it all. So this is how you get your peak load. It is not that peak load for entire building will come at one particular point in time. Different spaces will have peaks at different times. So it will calculate peak for each individual spaces and then sum it up. And that's how you get a peak load for your building.
Right. Thanks, Arjun. Next question. Can you please talk a little bit about optimization tab in DesignBuilder?
I think the optimization would go much longer than this webinar. You need a dedicated webinar for optimization. If you want to learn more about optimization, you can always go to your technical resource group. They can answer this optimization tab.
Right. Okay. Thanks. Next question. How can we maintain zone air relative humidity in detailed HVAC mode even after applying humidity set point control at zone level? It is not maintained within the given range. Can you please guide us regarding this?
Sure. If you want, I can just show you.
Sure.
Just share my screen.
Yeah.
If you go into detail, see, it also depends on your system, because it's right now it's a VRF unit kind of system. It does not have a capability of maintaining the relative humidity. If your system has that kind of capability, then only then you can add. So if I have, let's say, if I load a templates from somewhere, and if that template is having, I don't know. Yeah, so I guess this kind of system will be having capability of. So if you see this, this is set point manager. So you need to have a set point manager inside your space as well to zone group. And inside the zone group, you can set your relative humidity. Just a second. So if you see, you have Humidistat control over here, and you can just keep what will be the humidity levels over here. So humidifying schedule and dehumidifying schedule. You can just make a schedule of 50% or whatever humidity you want to keep, and then just place over here, and then it will maintain that humidity. Yeah.
Right. Next question. How to generate ECMs from DesignBuilder? I think you've already discussed that, right?
Yes. So ECMs, as I said, that there is no specific ECM tab on DesignBuilder. You need to enter all the ECMs manually. Let's say if you want to change your LPD, then just enter the LPD and then run multiple simulations.
Right. So they'll have to change every time and then export their results, right?
Yes. Yes.
Yeah.
There is an option to run parametric simulations in DesignBuilder, but it will use a lot of their computation power. And I'm not sure if parametric ability is there for all licenses.
Okay.
And if they have the license to run parametric simulations, I'm not sure.
Okay. All right. Right. So Next question, how to take combined metabolic rate in the activity template?
Combined metabolic rate as in, can you be more specific?
Yeah, so this question was asked by an anonymous attendee. So if you could detail out the question, we'll have Arjun respond to that. And that was our last question as of now. If you have any further questions, we'll wait for a couple of minutes and respond. So please write to us in the Q&A window in case you have any questions. Can you, so we have one more question, Arjun. Can you throw some light on CFD?
CFD is again a huge topic. It will be difficult for me to explain even like a scratch of CFD in 5-10 minutes. Even inputting the values for CFD in DesignBuilder is not very straightforward.
Okay.
So if you, I mean, it can be a dedicated series of webinars, if not one webinar for CFD.
Right. Any other tools that you would want to suggest to our participants if they are interested in doing CFD?
They can use SE streams. I mean, but it's again licensed, or
Yeah.
if they want to go for open source, there is OpenForm, which is open source, but they can use OpenForm if they know Python scripting.
Okay.
Yeah.
Yep. Thanks, Arjun. We have another question. So in the activity tab, we can select only one type of metabolic rate, which we would not do during the entire day. So is there any type of multi-metabolic rate?
No. There is one average metabolic rate in DesignBuilder that you can enter. And it will take that metabolic rate for the entire period of simulation.
Okay. So would you suggest that they can take an average of multiple metabolic rates or something like that? Is that advisable?
I mean, I would say take a weighted average, not area, but I don't know how they are going to do if they know that for 2 hours they will be walking, or and then 4 hours they will be sleeping, and then 6 hours they will be doing something else, and then take an average of that metabolic rate and then enter here.
Right. Okay. Thanks, Arjun. That's all for the questions as of now. So, Prasad, do you want to add something here?
No, I do want to thank Arjun for a really nice explanation of especially the results part and how he explained it. So that was very useful.
Right. Thank you, Prasad. So with that, I think we'll end the webinar for today. So thank you, Arjun, for such a great session today. And I hope our participants will be able to make use of the knowledge and can use the software better and more effectively now. And thank you, everyone, for participating today. Just one last note of advice that if you are stuck with anything related to your design for the competition, do reach out to your TRG members. Their email IDs are available on the Moodle platform as well as on our website. These bunch of the TRG members are extremely what I would say knowledgeable, and you can make the best use of their knowledge by getting in touch with them. Also, Arjun is one of our TRG members, so all DesignBuilder queries, you can start shooting to him. And with that, I'll end the webinar for today. We have another webinar tomorrow by PC Thomas, where he will be discussing the HVAC side of DesignBuilder. The webinar is at 11 a.m. So we'll see you then. Thanks.
Okay.
Bye-bye.
Okay. Bye, everyone.
Bye.
Bye. Bye.